Section 10.4, Part 2. We're going to recall what we did last time. We were focusing on finding the area in polar coordinates. So if we have a region like this, we would like to find the area of this, called this graph F. This is G, and the way we did this is the area is defined as 1/2 the integral. So this side here, call it alpha to beta, so alpha to beta. And what we do, we usually shoot an arrow out, so you got is gonna hit F and then G. So G is the furthest one, sorry, F is the furthest one. It's F squared of theta minus the closer one, which is G squared of theta d theta. Don't forget the d theta, it's very important. That's what we did last time. So, and then we ask you to try this question: find the area outside r equals 2 and inside r equals 4 sine theta. So first, r equals 2, it's a circle, right? It's a circle, radius 2. And the other one, r equals 4 sine theta, that's another circle in the upper half plane with radius 4, sorry, diameter 4. So it's gonna go like this. That's 4. So all this was covered in last lecture. So it says outside the circle centered here and inside the other one. So we are talking about this region here. They want us to find this area. Okay, find the area of that region. To do so, the area, we set it up 1/2. If you shoot an arrow out, the region starts at that point, call it alpha, and it keeps going on and on and on until this point, beta. But notice every time it's crossing the same graphs, exactly every time. So that's going to be the integral is going to be something d theta, so it's going to be something square minus something else square. So the further one from the pole, which is this one here, that's the circle in the upper half plane. And the circle in the upper half plane, the equation for it was the 4 sine theta. The one in the other one, the other circle, was just r equals 2, or g of theta is 2 square. Don't forget the squares. Now we still need to find alpha and beta. If you notice this point, and this point, that's where the two graphs intersect. So we can set them equal to each other. 4 sine theta equals 2. So sine theta is 1/2. So what are the angles? Theta is 1/2, pi over 6, and 5 pi over 6 from the table of trigonometric tables. So now it's good that you try to integrate this on your own. Okay, so what we do here is keep the 1/2. If you like, you can go, again, by symmetry, you can go from pi over 6 to pi over 2 and double that. And inside we get 16 sine squared theta minus 4 d theta. These two cancels. You can pull the 4 out. Pi over 6, pi over 2. You have 4 times, this is 1 minus cosine 2 theta divided by 2 minus 4. The 4 becomes 1. All d theta by 2, 1 by 2, 2. Keep the 4 out. Pi over 6 to pi over 2. Multiply the 2 in. 2 times 1, 2. And minus that one is 1. Minus 2 cosine 2 theta d theta. Keep the 4 out. Integral of 1 is theta. 2 integral of cosine is 1/2 sine 2 theta. From pi over 6 to pi over 2. These cancel. Substitute the pi over 2 for theta. Sine 2 times pi over 2 is pi, minus pi over 6, minus sine pi over 2 times pi over 2, pi over 6 is pi over 3. 4 times pi over 2 minus 0 minus pi over 6 plus sine that root 3 over 2. Now we can combine like terms. Multiply the 4 in, the 2 pi minus 2 pi over 3 plus 2 square root of 3. If you combine them, you get 6 minus 2, 4 pi over 3 plus 2 square root of 3. So this was about areas in polar. We can do arc length as well. Arc length in polar. How does it work? So we start, let r equals f of theta be a polar curve where theta ranges from A to B. Theta here is a parameter, and we can write x equals r cosine theta, or some people like to write f of theta cosine theta, and we have y is r sine theta, and again some people like to write an f of theta sine theta. From these two, I'm gonna differentiate both of them with respect to theta. So dx d theta is the derivative of f of theta, or derivative of r, which is dr d theta by the product rule, times cosine theta, plus r times the derivative of sine, which is derivative of cosine negative sine. So that's for dx. And we can find dy with respect to theta by differentiating both sides of y. Okay, and we get so then this is again dr d theta, derivative of keep sine the same, plus r, derivative of sine is cosine. So this way I got both dx d theta and dy d theta. So how do we find the arc length? So the arc length formula, if you remember from before, it was the integral of a to b, the square root of dx d theta, we can do it square, plus dy d theta square d theta. So that's why I found dx and dy, so I could substitute them into this formula. But before we do that, I'm not going to put it inside the whole radical. I'm just going to find on the side dx d theta square plus dy d theta. So I could find a formula for the arc length in polar where there's no x and there's no y. There's only r and theta. So to do that, dx d theta, we found it was dr d theta cosine theta on the top of the screen minus r sine theta. And then you can square all of this, plus dr d theta sine theta plus r cosine theta, again all square. What do we get for that? So we're gonna square the first one, d square r, or let me do it this way, dr d theta square cosine square theta minus 2r sine theta cosine theta times dr d theta plus r square sine square theta plus dr d theta all square sine square theta plus 2r sine theta cosine theta dr d theta plus r squared cosine squared theta. Notice all these cancel. Now to simplify this, we may look at this one and this one. We can factor dr d theta square, and what is left is cosine squared theta plus sine squared theta, which is 1. Plus, now we can take this one and this one. R squared is common, and that will leave sine squared plus cosine squared, which is also 1. So now, the arc length is going to go from A to B. Instead of dx d theta squared plus dy d theta squared, we can do r squared plus dr d theta square d theta. So this is the arc length formula in polar coordinates. Find, as an example, the exact length of the polar curve r equals 2 times 1 plus cosine theta. So the formula is right here. We need to find r squared. So r squared is 4 times 1 plus cosine theta all square, which is 4 times 1 plus 2 cosine theta plus cosine squared theta. And that simplifies to 4 plus 8 cosine theta plus 4 cosine squared theta. Also dr d theta, keep the 2 out. Derivative of this, it's 0 minus sine theta. So it's negative 2 sine theta. Now we go back to the formula. So the arc length, I'm going to write it again. That would help me to memorize it. dr d theta square d theta. So the thing is, yeah, we got r squared, we got dr d theta. How about the bounds? Where are the bounds going? So maybe you can graph this, or you can use Desmos to graph the given r, and you will notice it goes from 0 to 2 pi. This one we found it was 4 plus 8 cosine theta plus 4 cosine squared theta. And for the dr d theta, when you square it here, dr d theta, when we square it, we get 4 sine squared theta. 4 sine squared theta. And then we need to simplify as much as we can inside the square root. So let's see what we have. This one and this one, they add up to 4 because sine squared plus cosine squared is 1. And there's another 4 there, so that becomes 8 plus 8 cosine theta d theta. To 2 pi. You can factor 8 out as a square root of 8. That will leave 1 plus cosine theta. We know that cosine 2 theta, the double angle formula, has it's 2 cosine squared theta minus 1 or 1 minus 2 sine squared theta. So probably we're going to go with the first one because I want to have the negative 1 to cancel the 1 inside the square root. So I can say 8 is 2 square root of 2, 0 to 2 pi. And now instead of, so from here, if you divide the angles by 2, you're going to get 2 cosine squared theta over 2 minus 1. So I'm going to put that in here, 2 cosine squared theta over 2 minus 1 d theta. So L equals 2 square root of 2, 2 to 2 pi, 0 to 2 pi, these cancel. You can pull this 2 as a square root of 2, and that will leave cosine squared theta over 2 d theta. Next, what we do is we are gonna, if you, the given equation was this. If you graph it, it's in the right side. It's a cardioid that goes up to 2 and 4. So we were asking to find the arc length for the whole thing. So what we can do, we can go from theta equals 0, and then when you go all the way here, that's pi. So 0 to pi and double that. So we can say the arc length is going to be, because when you take this outside, so this times this is 2 times 2 is 4. So when you take that out, you're going to take it as an absolute value because we don't know if it's going to be positive or negative. So what we can do next is, if we like to use symmetry, which helps in most cases, is we can go from 0 to pi and double that. So you double that and 0 to pi. Now what happens to this one? Is it positive, negative? What's going to happen? Well, remember, when I'm saying 0 to pi, I'm saying theta equals 0 to theta equals pi. Okay, theta equals 0 to theta equals pi. And then what we do here is, so theta here now it's 0 to pi. So if you divide both sides by 2, that tells us, hey, theta over 2 is sitting in the first quadrant. In the first quadrant, everything is positive, so you can drop the absolute value like so. Now we have 8 times, remember the shortcut for the integral of cosine m theta d theta. It's 1 over m sine m theta plus c. So here we do 1 over the half sine theta over 2 from 0 to pi. So that will give me 16 sine theta over 2 from 0 to pi. If we do the work, we're going to get 16 sine theta of 2 pi over 2 is 1 minus 16 times 0. So the answer is 16.